Good evening, everyone. Hello, class. Thank you for saying hi. All right, so today we are going to review for the first exam. The first exam covers the first 4 chapters, chapter 1, 2, 3, and 4. In the review, which is in your MyLab Math, we have 30 questions. Earlier today, I emailed you. Make sure you look at your email box and download the file. Either that you can see that on your computer or you have the hard copy with you. Okay? So the reason is because the printout is so tiny, the words is so tiny. I even have trouble to look at it. And on the documentary camera is very not clear. So our solution is everybody has a copy. So when I say we are looking at number 10, and you are able to read the question on your end. Am I clear about that, guys? The first class, I give you 1% extra credit for agreeing with on the statement. The statement is it's my responsibility to read the announcement and it's my responsibility to read the email sent by the instructor, right? And earlier today, I sent you an email with the file. So you should have it. Yeah, if you still don't have it yet, please get it as soon as possible. Yeah, get it right now, because we are going to start a review now. All right. Okay, so we start from, I think, the most necessary problems. So let's start from page 2, question number 10. Everybody look at question number 10. Yeah, let me read the question. It's so tiny. I even have trouble to read it. Anyway, we look at this. This is a distribution, frequency distribution table, right? It's a grouped frequency distribution table. How many classes do we have? 1, 2, 3, 4, 5, 6, 7. 7 classes, right? The first class is 5 to 9, second class is 10 to 14, and so on. The last class is 35 to 39. And the second column, we have the corresponding frequencies for all the classes. Yeah, we have 30 values from the data set fall between 5 to 9. We have 35 values fall between 10 to 14, and so on. We have 2 values fall between 35 to 39. And what's our requirement? We need to find the lower class limits. Okay, let me write. We have 7 classes. The first class has a lower limit of 5, so we put a 5 here. Okay, you should be able to see what I wrote. I wrote pretty big, yeah. And then we have a 10. Anybody can tell me what's the class width? What's the class width?
5.
Awesome, it's 5. Okay, it's not 4. Yeah, it's 5. Very good. So if I know the smallest class width is 5, all I need to do is to add a 5, add a 5. So 10 plus 5 is 15, and 20, 25, 30, 35. Are we good with the first part of this question? All the class lower limits. And second part, we need to identify all the upper class limits. The first class has upper limit 9, right? Yeah, actually just the 9, 14, 19, 24, 29, 34, 39. Yeah, so those are pretty straightforward. So I have a 9, 14, 19, 24, 29, this is 34, this is 39. Yeah, pretty straightforward. Identify the class width. Most of you know is 5, which is very good. Is not 4, okay? The class width is defined as the distance between any two consecutive lower limit or upper limit. Very good. Next part where we need to identify class midpoint. Okay, look at the first class. The first class has a lower limit of 5, upper limit 9. 5 plus 9 equals what? 14, right? 14 divided by 2, what do we have? 7. So the first class midpoint is 7. Once we have the first class midpoint, all other class midpoints can be found by adding the class width. Yeah, 7 plus 5 is 12. 12 plus 5 is 17. 17 plus 5 is 22. Plus another 5, 27. Plus another 5, 32. Another 5, 37. Right? Yeah. And we can double check. For example, the last class is 35 to 39. 35 to 39, the midpoint right in the middle is 37, because 37 is 2 more than 35, is 2 less than 39. So it's right in the middle. So that's the class midpoint. The midpoint is the average of the lower limit and the upper limit. The next one, identify the class boundaries. Okay, so our smallest class lower limit is 5. What is 5 minus 0.5? 5 minus 0.5 is 4.5, right? Exactly, yeah. So the first boundary is 4.5. The 0.5 is like edge. It's like edge. Look at your computer right now. You're probably looking at your computer. So your computer has the screen, right? But not the whole thing is a screen. It has a rim, like edge. So this is kind of like a 0.5. This is a 0.5, the boundary. This is 0.5. So we subtract 0.5 from the smallest lower limit, we get 4.5. And then we are going to add 5, add 5, add 5, all the way to the last boundary. So with the 5, here we have 9.5. Double check 9.5 happen to be in the middle of 9 and 10, right? 9.5 is right in the middle of the first class upper limit and the second class lower limit. And then plus another 5, 14.5. Plus another 5, 19.5. Yeah, just keep adding 5, which is 5 is the class width. Add another 5, 24.5, 29.5, 34.5, 39.5, right? Yeah, you can see 39.5 is 0.5 more than the biggest upper limit. So that is the boundary, the biggest boundary. Any questions so far? Any questions so far? Okay, so the next part of this question is to find how many individuals included in the summary. How do you find that? How do you get a 91, Dustin?
By adding the frequencies together.
Awesome, exactly. The second column in the frequency distribution table. Yeah, add them all up, you get 91. Very good. 91 is the number of values, total number of values in the data set or the sample size. Awesome. So that's number 10. Are we good with that problem? Any questions? I'll count to 3. If nobody answer, I'm gonna continue. All right. Okay, number 11. Yeah, very tiny. Number 11 is also very tiny. We have a list of numbers, as you can see. Bunch of zeros, 2 ones, 1 2, 3 threes, 2 fours, bunch of 5s, 1 6, no 7, 3 8s, 1 9, right? Yeah, so that's the list of numbers we have. Yeah, what do we want to do for number 11? Read the question. We need to construct the frequency distribution table for that data set. Okay? Okay. So the first column, it's just a split half. Yeah, this is the first column together. It's just divided into two parts. Okay? Yeah. So tell me among the values, yeah, how many zeros do we have? Yeah, you can count it. Since those values are pretty small, I do not recommend you use calculator because they are just simple one-digit numbers, right? Yeah, you can count it. You can count the number of those values. It will not take too much effort or time. Yeah, tell me how many zeros do we have? We have 8. You're right. Yeah, if you count the number of zeros, you have 8. So the frequency for 0, the first value is 8. How many ones do we have? 2 ones. Very good. Really, how many zeros do we have? Let me count it. Let me get it closer. I need a glasses for this one. 1, 2, 3, 4, 5, 6, 7. Yeah, it is 8. Okay, very good. And we do have 2 ones. Very good. How many 2s do we have? 1, 2. How many 3s do we have? 3 3s, right? How many 4s do we have? 2 4s. 2 4s. Yeah, 8 2 1 3 2. 8 2 1 3. Yeah, that's correct so far. And how many 5 do we have? We have a bunch of 5, right? You just counted 1 2 3 4 5 6 7 8 9 10. Am I right? 10 5s? Yeah, 10 5s. How many 6 do we have? 1. How many 7 do we have? None, 0. Yeah. How many 8 do we have? I saw 3. How many 9 do we have? 1. Yeah. Kylie, you just missed a little bit, right? 1 0 3 1. 1 0 3. You missed the number of 8. Yeah. We have 3 8s. Yeah. So do you think we can do that? Do you think you can do that? This type of question? If you understand the definition of frequency distribution table, you know how to process. You just need to count it. The frequency of a value is how many times that value appears in the data set. All right? Okay, very good. Yeah, you have your paper in your hand, so read the question through, understand it very well. Next question we are going to go through is number 13. Number 13. Yeah, let's see what's going on in this question. We are given a grouped frequency distribution table, okay? Grouped frequency distribution table. The table below shows the frequency distribution of the weights of pre-1964 quarters, okay? Use the frequency distribution to construct a histogram. Does the histogram appears to depict data that have a normal distribution? Why or why not? A few parts. Let's do one part at a time, all right? So firstly, we need to translate from frequency distribution table to frequency distribution histogram, okay? Yeah, how many classes do we have? 1, 2, 3, 4, 5, 6, 7, 8. So 8 classes, that means we're gonna have 8 bars. Seems they all have 8 bars. That's no problem. Yeah, ABC all have 8 bars. And the frequency for each class is gonna be the height for each bar, okay? Yeah, the first class is the first bar. Since the frequency is 1, the height, how tall, how short, the height of the bar is gonna be only 1, very, very tiny. So you know what? Do we just get rid of B? Because B is not 1, right? The frequency the height of the first bar pretty high, is like 5 or 6, seems like. So it's out, yeah. And then I notice the second bar, the second class has frequency 4. So the second bar is supposed to have a height 4. They both, A and C both have a height of 4. And then we keep going. Let's see the third bar. How about third bar? Class number 3 has frequency 8. So the third bar should have a height 8, right? Pretty tall. Okay, A is out. We choose C. Do you see that? Okay, awesome. Thank you, Leah. Yeah, not super complicated. If you have been practicing in your MATLAB math assignments, if you are not falling behind, the reason some assignments have the precondition, you have to complete the previous assignment in order to start the next assignment. You know, because I want to keep you on track, not falling behind. That's for your good, for your own good. So the first part we choose C, no problem. Let's see the next part. Does the histogram appears to depict data that have a normal distribution? A little bit, but not very symmetric.
Yeah, it looks like the answers are cut off.
The answer, oh, hold on. Like that. Oh, the answer is cut off. It doesn't print. Oh, yeah, you're right. I don't know why. Yeah, mine has the same thing. Mine has the same thing. Yeah, the histogram appears to depict a normal distribution, but it's just roughly. Okay, if we read the 4 answer choices, does not appear roughly. It's already say roughly, so we can, you know, just roughly means as long as it start from a low and then reach high in the middle and then go down, finish at a low. That is kind of like a roughly symmetric. So the histogram appears to be normal distribution. It doesn't say roughly. D, the histogram does not appear. Okay, so we should choose C in this question. Not perfect, like strictly normally distributed, but roughly normally distributed, okay? Roughly normally distributed. As long as it start from low, reach high in the middle, and then go down at the low. Any questions about this problem? Okay. Next question, we're going to go over number 14. Yeah, read your question number 14. Let's see what we have here, okay? Tornado, okay, it's here. Tornado F scale. That is a frequency distribution table. Yeah, simple frequency distribution table. Yeah, among those, how many times hurricanes, right? No, sorry, tornadoes. So those are the scale of the tornadoes. So among those tornadoes that happened, 21 times is 0 scale, 19 times 1 scale, 1 times 2 scale, 2 times 3 scale, 2 times 4 scale. So that's what we have. And we need to construct, based on the given frequency distribution table, construct a frequency polygon using the data. Choose the correct graph below. By the way, this version might be different from your version. So even on your end, you try one time, and if you are not satisfied, you try again, and the computer will give, the system will give you a different version. Maybe some of the questions are similar or even the same, but some of the questions are new. Yeah, for example, sometimes they would let you to construct a histogram, but sometimes would let you to construct a polygon. Okay, what happened is we look at the height of those dots. We have 1, 2, 3, 4, 5 scales. So we should have 5 dots. Okay, 5 dots. And 1, 2, 2. Yeah, those 2 dots. Those 2 dots, as I can show you, those 2 dots that connect the x-axis do not belong to the frequency distribution table. They were there just to make a polygon, because the polygon has to be closed. So they have to make the graph touch the x-axis. So those 2 points do not belong to. And the 5 points are this one, this one, this one, this one, this one. Okay? Those are the 5 points. Yeah. Let's see. Do they have the y value equal to 21, 19, 1, 2, 2? 21, 19, 1, 2, 2. And what about this one? This one, those 2 are extra. And the 5 points are this one, this one, this one, this one, this one. Do you think that the part B is better, or part A is better when they describe 21, the y value or height, height, 21, 19 is not 1, 2, 2. Yeah, the last point obviously is different height from the fourth value, right? I would go with A, 1, 2, 2. Yeah, very good. You guys go with A as well. Perfect. And the last part says, does the graph suggest that the distribution is skewed? Yeah, it's skewed to the right, okay? The distribution appears to skew to the right. Yeah, or possibly, I'll choose D. I'll choose D. Not B, okay? What is B says? B says the distribution appears to be skewed to the left. Okay, so skew to the right means it has a long tail on the right, longer right tail. This is skew to the right. Skew to the left has a longer left tail. So our graph has a longer right tail, so it's skewed to the right. Yeah. Okay.
The book did a really good job of explaining skewed to the left and right as your feet. So like if it's right skewed, like your right foot, your toes are bigger on the right side. And if it's left skewed, like your toes are bigger on the left side of your feet, of your left foot. I thought it was an interesting way of looking at it.
Yeah, perfect. That's very good. Okay, so let's see what's the next question we're going to go over. Let's go to the next page. Number 16. Let's see, number 16. We have a 2-row column. Weight, high weight. Oh, okay. So the table lists weights and high weight mileage amounts for 7 automobiles. Use the sample data to construct a scatter plot. Use the first variable for the x-axis. Based on the scatter plot, what do you conclude about a linear correlation? Okay, so which one go on the x-axis? Weight go on the x-axis. Highway speed go on the y-axis. So horizontal is row 1, vertical is row 2, okay? So basically we are looking for the trend. Good news is this is a multiple choice question. Yeah. Good news is it is just choose one from the 2. Let's see. When the smallest value of weight is 2040. Do you agree? Among the weights, the smallest value is, is 2000. Yeah, it is 2000. It is 2040, right? Yeah. Tell me what's the corresponding highway speed when the weight of the vehicle is 2040? 39? 39, right? 39, yeah. Okay, so that means the point that closest to the y-axis should have a y value of 39. 39 means very close to 40. So what do you choose? Do you choose A or B? You choose A, yeah. So good news is this is a multiple choice question. Otherwise, it's gonna take a while or use technology. Do you agree, guys? Yeah, just use a couple of points to eliminate the answer choices that do not match the table. Yeah, let me repeat what happened. I first identified the smallest weight. I saw the smallest weight is 2040, so right here. The last second column. The corresponding speed is 39. So that means the point that is closest to the y-axis, the vertical scale, has a height or y value of 39, which is very close to 40. And I see that B is not close to 40. It's like over 30, a little bit over 30. So is A. Yeah, I hope you understand my logic. I use the method of elimination. I would not have the time to really graph or plot all those pairs. I'm not going to do that. And you know what? You do not need to do that either. Just use the method of elimination. Okay, very good. Thank you, Leah. Is there a linear relationship between weight and highway speed? Highway mileage. I'm sorry, not speed actually. Highway mileage. Yeah, mileage per gallon. Yeah, sorry, it's not speed. My bad. Yes, as the weight increase, the highway mileage decrease. So there is a negative. Exactly, very good. You guys great. Obviously, there is a negative correlation, right? Negative correlation because the linear trend goes down. Linear trend goes down. Very good. Number 17. Let's see number 17. What do we need to find? We have a few parts. Yeah, number 17 seems very long. Find the mean, median, mode, and mid-range for the data and then answer the given question. Listed below are the jersey numbers of 11 players. What is it? Randomly selected from the roster of a championship sports team. What do the results tell us? So basically, we're looking for mean, median, mode, mid-range. Okay, so measurement of centers, right? Okay, let me tell you the easiest way to do that. If you have TI-84 calculator, okay? Can you see my calculator? That's very big. Okay, so this is what we do. We are going to enter those values, 11 values, right, in a calculator. If you have a calculator, please do that with me. So first I go to stat and then enter edit. Yeah, I have a bunch of number already. I'm going to clear them all, okay? This is how do I clear the whole list. Go up to highlight the list 2 and then clear. And then go down, you'll see all gone. And go to the left, go up, highlight L1, clear everything. Nothing, right? Yeah, I just want to have a clean slate. Yeah. So I'm going to enter those values, so tiny. Make sure I don't enter the wrong value. Okay, I need to look at it closer here. So 11 values, we have 8. What is it? 45, 67, 45, enter, 67, enter, 7, enter, And then 68, enter. And then 3, enter. And then 46, enter. 53, enter. 85, enter. 51, 93. 51, 93. Everybody, make sure I don't enter anything wrong. Let me double check though. Let me read it and you listen, okay? The first value seems 8, 45, 67, 7, 68, 3, 46, 53, 85, 51, 93. Okay, that's the boring part. That is the tedious part. Okay, now it's getting better. Let me turn on the light to see if it helps us to see.
Where did you go after you hit stat?
Here's what?
After
right now?
After you hit stat, where do you go to?
Oh, stat edit. You right away will see edit and just confirm the edit. EDIT.
Okay, I got it. Thank you.
Okay, no problem. And then now is the fun part, okay? We go to stat again. Go to stat again. And this time, you still see the edit, but we are not going to there. We are going to enter, you see my finger. Go to the right one time and hide the calculation. CALC, okay? Calculation. And the first item on the drop-down menu of calculation is one variable stats. Confirm that. Okay, confirm that. We need to do some work because I stored the 11 values in L1, right? As you can see, I have L2 because I did something earlier. So I'm going to change that to L1. Yeah, we're going to change that to L1. L1 is go blue second one, okay? Blue second one. You see the L1 here, right? And leave the frequency list empty, or sometimes it depends on your calculator. Sometimes if you don't enter nothing, it won't let you to go proceed. So you can just push 1 there. But I would keep the empty. And then calculate. I'm going to go too fast. So make sure the list is L1, the list where you store your data, and then calculate. Tell me, do you see the same thing here? Do you see the same thing? Yeah, everybody, if you have a TID for calculator, you should see same thing. The time-consuming part, the time-consuming part is just to make sure you enter those values correctly into the calculator. Yeah, be very careful. If you enter one number wrong, of course the data, all those statistics will be different, right? Yeah, make sure you enter the values correctly. All right, what is X bar here? X bar is our mean, okay? X bar is our mean. So part A, yeah, let's see how do we round it. Let's see how do we round it. It says type an integer or a decimal rounded to 1 decimal place as needed. The rounding is so important. I'm not kidding. Many students mess up that. When I look at their test result, and I feel that's such a shame because so close, but rounding messes the question up and they do not get a point. The system clearly says round the decimal to 1 decimal place. You're going to follow the instruction, okay? Yeah, on your calculator, the mean is 47.8181A1A2. Yeah, round it up. So we keep 1 decimal place is going to be 47.8, right? You see, Mimi, if you enter 47, you get it wrong. You see what I'm talking about? You do not enter 47. What should you enter? What should you enter? Tell me. Yeah, what should you enter though? No, no 48. Not 48. Did you hear me? The rounding? Yeah, look at your classmate. How come they all get a 47.8? Keep one decimal places. One decimal place means you're gonna keep one digit to the right of the decimal point. Very good, very good. Don't blame me, I do not remind you, okay? I keep saying the same thing over and over. You need to read the sentence in the parentheses during the when you take the exam, and you need to round according to the instruction. They ask you to round the decimal and keep one decimal place. You have to do that, okay? All right, what's the median? How do we find the median here? Look at your calculator. Do we have a median here? We go down. Do you see MED? Yeah, go down a little bit. This is a long list. Do you see MED? MED, yeah, is 451, right? Is right here. You don't have to do that manually if you have a calculator, okay? If you do not have a calculator, I think you should get one to make your job easier. So the median is 51 right here, okay? And next, find the mode. Yeah, do we have a mode in the list? I don't think we do. Yeah, we don't have a mode, but mode is not that difficult to find, right? Yeah, look at those numbers. Do we have a repeating numbers? I don't recall. They are all different. Just double check. No, there's no mode, okay? There's no mode. Choose B. Not for jersey numbers. What is even jersey numbers? Players? Okay.
The question is for jersey, like the players' jerseys, and they're not going to have repeating numbers.
Yeah, exactly. They are the same team, right? If the same team, they are not going to have the same numbers. Because the number actually label their kind of like a name, represent their names. Okay, so part D, find the mid-range. Let's see our list. We don't really have the mid-range, but we have maximum and the minimum, okay? Minimum is 3, maximum is, hold on, here. Minimum is 3, maximum is 93, minimum plus maximum is 96. Divide 96 by 2, what do you have? Divide 96 by 2. Nope, not 90. Okay, so that exactly is the common mistake I mentioned when we went over that part. Yeah, I said mid-range is different from range. Okay, mid-range is different from range. They sound so similar, and they both use extreme values. But mid-range is minimum plus maximum over 2 divided by 2. Range is maximum minus minimum. Range is a measure of variation. Yeah, okay, do it again, please. Minimum is 3, maximum is 93. Add them up, 96 divided by 2, what do you have? 48, right? Dustin is right. Yeah, that's exactly what I said. Based on my experience, mid-range is different from range. Mid-range is a measure of center. Mid-range formula is mid-range equals minimum plus maximum all over 2. Okay, is the average of minimum and the maximum. Yeah, please don't forget that. The last part, what do the results tell us? Let's see. Since only 11 were in the sample, cannot give an meaningful result. B, the jersey numbers are normal data and they do not measure or count anything, so the resulting statistics are meaningless. C, the mid-range gives the average, while the median give two different interpretations. Yeah, it does cut off the rest sentence, unfortunately. D, the mean and the median give two different interpretations of the average for typical jersey number, while the mid-range. Okay, let's see. Listed below are the jersey numbers of 11 players randomly selected from the roster of a championship sports team.
I think the question they use confuses everything because they're using jersey numbers, which there's no data to it really.
I don't even know what is jersey number. What is the culture? What is jersey number means?
It's like for soccer, football, basketball, like all the players have like their name and their number on the jersey.
Oh, so how many supposed to be in a team though?
Every sport is different.
Listed below are the jersey numbers of 11 players randomly selected from the roster of a championship sports. Probably many, but randomly selected 11. And I think I would say it's meaningless because those are not numerical. They are categorical, qualitative. Those measurements do not mean anything. It's like a name, remember? The jersey numbers are nominal. Oh, nominal. Okay, I choose B. Do you agree, guys? The jersey numbers are nominal data and they do not measure or count anything. So the resulting, yeah, I would choose that. Do you agree? Okay, good, cool. B, yeah. Because it's not measure, doesn't measure or count. As I mentioned earlier, we agree is like the number on the shirt. At least I know that. So represent their names, right? Yeah, number 11 is who and who. The name is, so it's just a name, is a label, is a nominal. All right, so that is number 17. Let's do number 18. Next page. So here I saw 1, 2, 3, 4, 5, 6, 7, 14 values. Hold on, 1, 2, 3, 4, 5, 6, yeah, 14 values. Did I cut off anything? Oh, I hope I did not cut off it is 14 values, right? Otherwise it's gonna be difficult to, Okay, so what are we gonna do?
It doesn't look like you cut anything off on the values because just how the
on the
columns
right
are
side?
aligned. Yeah.
But it cut off from here, if you can
Yeah.
see. It cut off from here, and the distance between those two values is smaller than this. I think it probably didn't cut off this one. You see what I'm talking about? It's cut off from here, this right here, right?
It doesn't
So
look like
if
you
there
cut it
was-
off on my piece of paper. It looks okay to me. It looks like it's far enough away from the edge. So either way.
Yeah, I think we have the full data values. That's what I'm concerned. Okay. Yeah, range. We need to find a range, standard deviation, variance. Yeah, doesn't matter. Even we are losing numbers, we are going to just do it pretending just the 14 numbers. Probably just the 14 numbers, okay? Yeah, how do you use the calculator to do that, guys? How do you use the calculator to do that? Let's do that together. Turn on your calculator. Second mode, you go back, okay? Second mode, you go back, and then you can start over. And I would go to Stat, Edit, and this time I use L2 because I used L1 earlier. Yeah, if you really don't want to use L2, you just clear L1. It really doesn't matter, okay? L2, I'm going to enter those 14 values. 4, 3, 13, what's that? 5, 18, 16, 6, 16 and 6. And then second row, 12. Oops, see? Sometimes. So that one is 6. Yeah, 16.6. And then second row is 12, 11. Is that 18? 15, 2, and 20, and 14. All right, let me double check. So I have 14 values because the calculator is waiting for me to enter the 15th. And let me double check. We have 4, 3, 13, 5, 18, 16, 6, 12, 11, 18, 15, 2, 20, 14. Okay, awesome. So I would not mind spending more time double check what I entered in the calculator because that's the critical step. And then we go to stat, calc, one variable stats, and be careful. I used L2. I don't know which one you use. I think there are 6 lists in the calculator. So I'm going to change to L2. How do we change it to L2? Blue, the second, 2. Okay, second, 2. You would see a blue L2 on top of 2. So that's how you get the L2. And then go down to calculate. Tell me, do you have this? Awesome. Very good. Okay, tell me, how do we get a range? Yeah, this time is asking range, okay, not mid-range. This time we are looking for range. What's the range of the sample data? Range, what's the formula? Range is a maximum minus minimum. Very good. So let's see what's the maximum. Minimum is 2, maximum is 20. So the range is 18. Good job, guys. You did great. Yeah. How do we find the sample standard deviation on the list? How do we find a sample standard deviation on the list? We see S sub x and sigma sub x. Which one is our answer? S sub x or sigma x sub x? S. Very good. S is the sample standard deviation. Okay, just ignore the the sub x. Yeah, let's see how do we run the answer. The standard deviation round to 1 decimal place as needed. So what should you enter in a cell? S sub x. How do you round to 1 decimal place? Perfect, you guys, great. Very good, very good. Only keep 1 decimal place. Very good. 6.1, okay. How did you change to L2? Okay, so you see this blue. Hold on. Do you see this second? Is blue, right? And you see the number key, number 2. On top of number 2 has L2. Do you see L2? Which is supposed to be blue. It doesn't really look very colorful on the camera. So you're gonna enter second 2. Yeah, second 2 will give you L2. Am I clear? Okay, perfect. Where were we? Okay, so we got a standard deviation. How do we find a variance, guys? How do we find a variance? Huh? Variance is not on the list. Unfortunately, you have to take a little bit effort to get it done. Okay, this is what I would do. I would write down on the scratch paper when you go to the testing center, asking scratch paper. Okay, yeah. When I send your test there, I will put it on note, give the students scratch paper. So on the scratch paper, you write down the value for S sub x, which is the standard deviation. And then on your calculator, you are going to go to second mode, okay? Second mode means you go outside, like get out of the statistical mode. And on the main screen, you are going to enter the standard deviation, 6 point, oops, do you guys see my screen protector? I just wonder if I have the screen protector, would you see it too? Hold on, let me close that. Oops. My older computer is really bad. Good news is I just ordered a new one. And we would have better. Okay. Yeah, square it. You are right. Exactly. So you enter the value of the standard deviation, 6.129105487. And then you raise that to the power of 2. This key, okay? Go up to the power of 2.
We have to square the exact value, or can we do the rounded version?
Yeah, that's a good question. I would write the exact value in case the rounding needs more. That's a very good question. As a math person, I would go as precise as possible.
Okay, got it. Thank you.
Yeah, so let's see. It doesn't take too much time. Yeah. Let's see how do we round it. The variance round to 1 decimal place as well. Yeah. So what's your answer, guys, for variance? What do you enter in the system? Pretending this question is on the... Awesome. Awesome. You got it great. Bless you. Very good. Okay. Yeah. Majority got it right. Perfect. Very good. You all got it right. Okay. So is that clear? Earlier we have a question to find all the measures of center. This question is all the measures of variation. Yeah, variation, be very careful. The variance is not directly given. You would have to write down the standard deviation and then raise the standard deviation to the power of 2 to get a variance. All right. So that's number 18. That's number 18.
On the calculator, can you go through the? I think you talked about it earlier, but I was trying to figure it out. But can you go through the calculator on the stats and describe what every one of the symbols are and what they represent?
Oh, okay, sure. So if we go back, stat, and go to the right one times calc, and confirm one variable stats, and this is the question we just did, right? Go down, and still there. Yeah, let me go through what we have. The first one, X bar, sample mean. Second one is the sum of all the values. We don't really use it. The third one is the sum of the square of each value. We don't really use that. S sub x is the sample standard deviation. Sigma sub s sub x is supposed to be population standard deviation, but I never use that. It's kind of like modified. And n here is the number of values. We have 14 values in the data set. And next is the minimum value. Among the 14 values, the smallest value is 2. And then Q sub 1. Do you remember what is Q sub 1? The first quartile, right? And MED is the median. Yeah, median, perfect. Yeah, median is the number in the middle, or the P sub 50, the 50th percentile, the number in the middle. Q sub 3 is the upper quartile, or the third quartile. And then maximum value. And that's the last one. Okay?
Thank you.
Yeah, you're welcome. You know, when I was at school, my specialty is statistics in graduate school. Even in graduate school, I did not use all the technology. Everything is manually. You know, how did I learn those? I YouTube. I learned by myself because my teacher never showed me this, and I did not take those class in this country. Graduate school, yes. Graduate school, yes, but we did not use technology. Mainly the theory. So whenever you want to figure out something, so many channels, right? So many resources. YouTube, Google, you know, our textbook, yeah, the optional media that you see in MyLab Math. Well, you can just ask me, right? Okay, so that is number 18. Do we have one more part here? What important feature of the data is not reviewed through the different measures of variation? Yeah, help me with that question. It's a multiple choice question. What important features is not reviewed? The measure of variation review nothing about how the numbers. The measure of variation reviews nothing about the pattern. The measures of variation do not review difference between largest and the smallest. I would choose B. B as in boss. What do you think? Let me see A. The measures of variation reveals information about the scale of. No information about the scale of data. Scale of the data.
I don't know. It's a weird one, but I chose A just because you don't know how big the hurricanes are, but it's C.
It is A. I mistaken variation as a variance. Yeah, range as a measure of variation does reveal the difference between maximum and minimum. And it does shows the pattern over time. It does show how the hurricane spread. Yeah, definitely is A. The correct answer is A, okay? A as in apple. Yeah, be careful, the word variation is very close to variance. But variance is just one type of a measure of variation. Yeah, it doesn't say anything about scale. All right, so the last part, we should choose A for sure. Any question about number 18? We have one more part? What is that? Years. Okay, I think you can figure out yourself. Oh, let's do it. So what is the number of hurricane? Okay, number of hurricane. Part 1, part 2, part 3. What is that? What important features?
I think it's supposed to be the units at the very end. I think for number 1, it's hurricanes.
Yeah. Oh, range. Okay, I got it. The unit for range, the unit for standard deviation, and the unit for variance, right? Yeah. The unit for range is hurricane. The unit for standard deviation, still hurricane. The unit for square of, variance, which is square of standard deviation, is going to be hurricane square. So C, A, D. All right. So this one, hurricane, this one, hurricane, and this one, hurricane square. Yeah, this is a printout. When you go to the MyLab Math, of course, it will show better. Yeah, this page does not cut out much. You cannot imagine how much effort I try to print this file out, because the setting is different from other assignments. In the beginning, it would not let me to print, and spend a lot of time to finally print it out. So let's go to number 19. Is this about the range rule of thumb? Okay, very good. Range rule of thumb. I think this probably need a go over. Thumb. Range rule of thumb. Let me see what time. We have 20 minutes. We have more important questions to cover. Yeah, let's get this done fast. Okay. So the first thing we need to do is significantly low. How do we find a significantly low? X bar minus 2s. Tell me, is X bar given? Tell me, is X bar given?
Yes,
Read the question.
It's the 27.67.
Correct. Very good. 27.67. And tell me if the standard deviation is given. 1.15. Exactly. Okay. You know how to calculate this, right? Yeah, you do it yourself. Yeah, that's the significantly low value. Whatever less than that is significantly low. And also we need to find a significantly high. Okay? Yeah, how do we find a significantly high? Do this, X bar plus 2s. All right, X bar plus 2s. And X bar is 27.67 plus twice of the standard deviation. And that value gives you the significantly high. I'll leave this for yourself. Can I? Is okay? We don't spend time. And also read the sentence in the parentheses. It says, type an integer or decimal, do not round. Do not round. What does that mean? It means do not round. What do you have on the calculator? Just enter that. Do not round it. Okay. All right. So I want to do the last page. Is percentile. This one percentile. There's a group frequency distribution because on the exam I see. Do you guys actually watch my video? I'm gonna ask the video again. You know, the first of all, I only did the exam one time, by the way. Well, at least when I did my version of exam 1, I saw this question. Okay, I'm gonna show you the video. You should be able to find it in your email, by the way. Let me switch the camera. Switch the camera.
So I have some questions about how the test is administered. When do we need to take the exam by?
Yeah. After this class, either tonight or tomorrow, I will email you. You are able to take your exam 1 in the next week, Monday, Tuesday, Wednesday, Thursday, Friday, whenever you feel comfortable, whatever the time is convenient to you, you go there to take the exam. How many minutes do you guys need? How many minutes?
You said something about having it be 3 hours, just so that way there's no time crunch. I don't think we need 3 hours,
You probably don't need 3 hours. I'll give you 3 hours though.
Sure.
Yeah. So let me write it down in case I forgot. So 180 minutes.
So what I heard you say, I think, is that like after today, you're going to open it and you'll be like closing it, I don't know, like Sunday, what would it be, like the 30th? Or not, the October 1st? Like how long, I guess, are you going to have it open?
So either tonight or tomorrow, I will email you and I will let you know what is the time window for you to take the exam. Okay?
Okay.
Does that sound good? I have not changed that. I have not changed that yet. I want to show you this video because when I did exam 1, I encountered this problem. And let me firstly change the camera. Share black whiteboard, share application, this one. This one. It's not sharing. Oh, yeah, it is sharing. So, which video? Let me see. Finding important stat. This one. Oh, yeah, this one. Okay, let's watch this one. I think something wrong with here, but this one looks different because you have to change the window. Go to window. Yeah, we should go to window, okay? Very important here. So this is the correct T-square. We have to go to Windows to fix the values. All right, you might or might not see this question because everyone has a different version. But when I firstly tried the exam, I saw that problem. Question: how many questions is it? You know, maybe I don't remember actually. How about I email you? You will be sending this video to our email. I will not because I already did. Okay. Look at my email. I emailed you that long time ago. I will not do it again because I emailed you already. Okay, so, okay.
Are you able to show us how to do? I'm trying to find it now. It's like question number 28. Trying to find probabilities on the calculator.
Yeah, calculator 28. Let's see, do we need it or not? Okay. Yeah, I'll show you. Let me share my camera. Share camera. HD camera. Share camera. Okay, let me read 28. A social security number consists of 9 digits. Particular order. Repetition is allowed. After seeing the last 4 of a receipt, randomly select the other digits. What's the probability of getting the correct social security number of the person who was given the receipt? I remember we did this on Tuesday. Yeah. So here, let me show you. Okay. We have 5 digits. 1, 2, 3, 4, 5. Let me see your question. Yeah, Leah. Yeah, 1 more 0. Exactly. 100 gram. 1 over 100 gram. Yeah, Leah, would you like to explain to us why is 1 over 100 gram? 100K, I'm sorry, 100K.
I'm not gonna lie, I had gotten it wrong, and then it gave the same, like it gave me the answer, and then I tried again, and then I realized that that's what it is. I don't know why.
I'll explain. I'll explain. It's okay. So this is a classical probability model, right? For classical, we need 2 numbers to find the probability. One on the top, the other on the bottom, right? Yeah. Since it's a classical, we want to see how many outcomes, different outcomes in a sample space. How many outcomes in the sample space? The number of outcomes in the sample space is the number of possibilities of those different social security numbers. We do not consider the last 4 digits, okay? Only do the first 5. Let's see how many sequences, because the order does matter, right? Yeah. How many sequences do we have? So in order to complete this task, we are going to have 5 steps. First step is to put number here. How many options do we have to put a number there? We have 10. You know, we assume 0 is fine. You know, I actually do not know if the first number could be 0 or not. But yeah, we pretend 0 is fine. Yeah, if you see anybody has first digit is 0 on the social security number, let me know. So 10, okay? And the second step, we're gonna put a number here. How many options do we have? Knowing the repetition is allowed. Repetition, yeah, still 10. Very good, still 10. It doesn't matter if a number you already used or not. You can, so definitely you can repeat, you can have repeated values in the digit in the social security number. So same thing. This step, we have 10 options. This step has 10 options. This step has 10 options. And the multiplication rule, remember, multiplication counting rule. Multiply them all together. We have 10 to the power of 5th, or 1, 2, 3, 4, 5. 100K. That's the denominator. And then how many among the 100K options, how many of them exactly the same with the one on the receipt? 1, right? Yeah, the receipt has exactly just the 5 digits the first 5 digits of social security number. Did I answer your question?
Yes, ma'am. Is there a way to do these on the calculator, or does it all just need to be done by hand?
You have to do it by hand, yeah, because every question is different. We do not need a calculator on that. We do not need a calculator on that. Yeah, you just enter that to the cell. Yeah, we do not have a because probability problem, they are order problem. You have to identify the denominator, you have to identify the numerator. Of course, the calculator can help you to convert a fraction to decimal if you want. Let's see this question. They ask type an integer or simplify a fraction. So you have to enter a fraction, then you don't really need a calculator at all. How about this? Since you ask, let me show you how do you simplify a fraction using calculator. How about that? Very cool. For example, let's enter 30 over 36. This fraction is not simplified, right? Suppose this is a probability. If you enter this one, the system will mark it wrong because it's not in the simplified form. But if you have TI-84 for calculator, and you really don't know how to simplify manually, you can do this. Math, you see this key, my thumb, math. And the first one is fraction, right? Fraction. And then enter again. What do you see? Do you see 5 or 6? That's how do you simplify a fraction using TI-84 calculator. Does that sound good? Okay, very good. Yeah, I hope this helps. Yeah, you would have to calculate on your own, but the calculator can help you to process the result you already got. Yeah, you have to understand the probability problem in order to do that. Okay, sorry that we ran out of time. So I would say practice. If you have any questions, I will just feel free to email me. Waiting for my email about the exam 1, okay? Your responsibility to read the email I sent to you. I have been sending you many emails, including the videos. I'll say, oh, hold on, let me take a picture of the attendance. Okay, we're done today. You guys have a good night. See ya.